So the question says, in an examination, there are two sections, section A and section B. And the marks carried by the question of section B has decreased by 25% as compared to that of section A. So questions in section A carries more marks. Now, if a student has to score same marks in section A and B, how much more questions should he do in section B as compared to that of section A? If he has to score same marks. So let us see the equation between the marks. The total marks of a section is equal to the number of questions that he has attempted and the marks carried by each question. So M is the marks carried by each question, and as N is the number of questions that he has attempted, and total marks equal to the total marks of a section that he'll be able to score. We are assuming that he'll do all the questions right. So what information we have got is that he has to score same marks in section A and B. So in both the section, the total marks would be same. So the product of M into N would be same in section A and B. Now, but the marks carried by question B, so let us suppose in section A, the marks are M, MA or M, and the number of question is N. So in section B, we know that the marks are 25%, the marks has decreased by 25%. So that is only 75% of the marks of marks of question in section A. So 0.75 M. So the marks carried by question of section B would be 0.75 M. So now we have to calculate the number of questions that a student would do in section B so that he gets the same marks. So let it be N dash if he is doing N number of questions in section A. So from this what we'll get is, we'll get an equation because the product has to be the same, M into N. Now M into N is equal to 0.75 M into N dash. Now M and M gets cancel. So N dash is equal to N by 0.75, or we can also say we'll remove this decimal and we'll do 100. We'll put 100 over here. So this becomes 25 fours are 25 threes are, or we can say that N dash is equal to 1.33 N. So N is the number of questions that he has done in section A, and N dash is the number of questions that a student does in section B. So how much percentage the question was asking, how much more questions should he solve in section B? So the number of question, if suppose is 100 in section A, then number of question that he has to solve in section B is 133. It's actually 1.33 into N. So the change is 0.33 upon 1, because we are assuming that 1N is there in section A, and the change, that is difference between the number of questions in section B and A, is 0.33 N. The change is 0.33 N upon the number of questions in section A into 100. So it comes out to be 33%. So the answer is 33%. So in section B, the student has to do 33% more questions because it has decreased by the value of question, the marks carried by question has decreased by 25%. And there's a simple method also to solve this. As we have seen in the concept video, if this product M into N has to remain the same, and if it is decreased by 0.75 because it has reduced by 25%, so M has become 0.75 M for section B, 0.75 M. So N has to become N by 0.75. So because the product has to remain same, M into N, so the product has to remain same, this M into N has to remain same. In section B, this m has become 0.75 m. So n becomes n upon 0.75. So 1 upon 0.75. So 1 upon 0.75 becomes 1.33 as we have seen, and the answer would be 33%. So the number of questions a student has to answer is 33% more question he has to answer in section B.